Hi guys, welcome to lecture number 6. I hope it has been a great experience so far till the lecture number 5, and I hope to continue the same way. Please give me your valuable suggestions in the YouTube's comment section if you have any. And now let's talk about lecture number 6. In this lecture we are going to talk about different ways of persisting data inside a Docker container. Specifically, we'll be talking about volumes. Now let's jump into the agenda for today. We'll start with the introduction to volumes. We'll also look at some different types of volumes. We'll find details about the volumes. We just dive into the container and see where the data is actually stored, what all things are required for a volume, and how Docker creates a volume. Then we're going to see how to use them in a Docker run command. And at the last, we'll look at how to use them in a Docker file. So what are different ways of persisting data inside a Docker container? So the first, as we talked about, it's volumes. Let's just concentrate on the arrow that has volume near it. So the container is pointing towards an orange area, which is the Docker area. So the volumes exist inside the file system, but they are in the bounds of the Docker area. So that means Docker has control over it. And obviously, they're platform independent as well. So if you port this image to some of your friends, they'll be able to use it because the path inside the Docker area is controlled by Docker. The second way of persisting data is via the bind mounts. This also is a persistent storage. However, in this, the bind mount resides in that orange area, you can see that, and this orange area is now the file system and not the Docker area. So the file system is actually controlled by your host. So if you're on Windows, you'll have a different file system. If you're on Linux, you'll have a different file system. So that is why the bind mounts created are not platform independent, and they are part of your host file system. So the paths may actually conflict, and the container may not run properly. So it is always suggested to create a volume instead of a bind mount. Then we also have a temporary storage, but it is only available on Linux containers. So it's called a tempfs mount, temporary fs mount, right? And you can see the orange area. It resides in the memory and not the file system. So as you can see inside the memory, every time you switch off your laptop or you turn down the computer, the memory is going to flash. All the data inside it will be wiped out. So this is why it's called a tempfs mount. This might give you a faster access time because it's in the memory, but the data stored inside it will not be persisted after the Docker is killed, after the container is killed. So these were the three types or the three different ways of persisting data inside a container. But we'll only be looking at the first one, volumes, because they are the most important ones and they are the only ones we'll be obviously working with. So there's no point talking about the other two. But if you're curious and you want to read about them, I will share the link in the YouTube's description. So now we'll talk about the different types of volumes. The first type is the host-only volume. And look at the syntax at the bottom of this slide. We first write the Docker run command. To attach the volume, we use -v. Since it's a host-only volume, we'll give the source, the path on our local host. Then we'll write the path existing on the destination, which will be our Docker container. And after that, we can also specify an access type. That is why I have included that part in the square brackets. and then we write the image name, obviously the image that we want to run in this container, and at the end of it we'll write an optional command. If you don't write in command, the command written inside your Docker file, that will be executed, right? So let's switch back to the terminal and see this in action. So I'm back in my terminal. So the command is docker run. Remember to use -ti because we want to be able to send our control C events back to Docker so that the terminal can be killed. Also, in order to have a terminal back to us so that we can interact with Docker, this is actually needed. If you don't write this, the container will run and it will finish, and without giving you some terminal to access it. So make sure you use the TI. Then we use the -v option, as I've written down there. We first specify the source directory. In my case, it is going to be the pwd. So one thing to make sure is that you cannot mount a file. You'll always have to mount a directory. So I'm mounting my current working directory. That is why I've written $pwd. So this is going to expand. It is just a normal bash expansion. Then I'm going to write colon, the separator, right? And then I'm going to write the destination path inside my Docker container. So let's say I want to map it into the OPT folder. Then the image that we created yesterday in the image that we created in the last lecture, day 5, I'm going to use that. And I'm going to specify a command bash so that I enter into the bash shell. And let me just show you the contents on the local host, right? So I have two files, commands.md and readme.md. So when I mount this directory, my present working directory, right, till day 6, when I mount it in Docker, I will see these two files inside the Docker, because I'm mounting this folder to a Docker container. So I'm going to uncomment this command, run this, and you see that I've entered into the shell of the Docker container. Let's do an ls on the OPT folder, right? We see these two files here. And let's create another file in this folder inside the Docker container, right? So let's say the file name is I should persist.txt. I'm going to create this file, right? Okay, I created this file in the root. Let's move this file, right? Inside the OPT, right? So if I go into the OPT, now I have a third file which I want it to persist. So when I exit this container, right, and let's also see the container, you can see this, just one container is running, and that's my Minikube. So no other container is running, right? Since I have exited the docker run command, the container was killed. So now again we'll start the container using the same command, right? And let's see if the file is actually there or not. Let's go into the OPT folder. Yes, the file exists. And why is that? It is simple, because we mapped our current working directory into the Docker. And then when we created a file inside the container, the file was created here as well. You see that the I should persist.txt was created on this folder as well. So that is why when we mount this volume again onto Docker, this file obviously will show up there as well. This is why this was called a host only volume, because we specified the host path while mounting a volume. This is the command, right? So let's also inspect something about this container, that where is what all information is being stored about this volume. So um, let's run this, and I'm going to open another terminal. I'm going to split it vertically, and since that container is running, let's find out the container ID. The container ID is the first one, right? Day 5. So I'm going to copy this, and then we inspect up something about this container. So the command to inspect is docker inspect and the container ID. So all this information was available with us. I'm going to skip most part of it, but I'm going to talk about the mounts, right? Because the mount is what we created. Right? And state. Okay, so let's look at this part. So the type was bind, and the source was my present working directory, which is day 6 folder, and the destination was /opt, and you have this RW, this is called read write. So by default, Docker is keeping this folder as a read write mode. Let's try and change this. Now I'm going to get out of this container, so this container will be killed, right? So as you can see, now I have just one container. Let's create this container again, but this time I'm going to mount this volume, the same volume, into a read-only mode. So the word is RO. So as you can see in this, we can give the access type. It's optional, but if you want to give it, you can give the access type. So I'm using the RO type, so the volume this time gets mounted as a read-only volume. Let's run this again, and I'm going to copy the container ID this time from here only. No need to write the another command. Let's see the OPT, nothing special here. We'll see the file again, and now we do docker inspect. This is my ID. So when I do this, you see, now we have read write is false, and we also have now the mode, because you have specified the mode. By default it was read write, and now the read write is false since we have kept it as read only. So this was host only volumes. The second type is anonymous volumes. Anonymous volumes and the named volumes, they are quite similar. Just the fact is that in the anonymous volumes, as it is anonymous, there is no name for it. And the named volumes have a name. That is the only difference between the two. But there is something different when we run this. So now I'm going to mount the same volume that we used earlier, but this time I'm going to mount it as an anonymous volume. So we do docker run -ti so that we get a terminal, -v for the volume, /opt, and then my image name. See that I have not given any access type because this will be controlled by Docker. And I have not given the source because this is not my host only volume. It is an anonymous volume. So I don't have to give the source. I just want to give where the volume, which will be created automatically by Docker, and it will be mounted into the slash opt in this image, and this command will be run, right? So let's go into the slash opt. You see that now we don't see the readme files that we had earlier from the present working directory, because we are not mounting our host path anymore. We're just mounting an anonymous path. We don't know where it exists. All we know that the slash opt is where the data will be persisted. So anything that you create in slash opt will persist. So let's see that. So I am going to live.txt. I'm going to make this file in the slash opt folder, right? And let's echo some hello inside this, right? Let's see. Yeah, this is having the content. Let's exit this. Obviously the container is killed now. You can see that with docker container ps. The container is not living anymore. So now let's go inside the container again and see if that file that we created is there or not. So we are inside. What just happened? We created a file inside it, used the volume, but why can't I see that again? There's something fishy here. So what happens is that you guys used anonymous volume. There is no name for it. We don't know how to specify that. So when you run the container again, you have to provide a directory, right? Docker does not know, which folder are you trying to mount inside the opt. You have to mount something inside the Docker the next time, because you have saved the data. The data was saved, but we don't know where it was saved. If we know where it was saved, we can just mount that directory again to Docker, and that file will be present. So let's find something really cool about it. Although this is not something you want to do, because anonymous volumes are hard to manage, since you can see that we do not know what is the name or the path where the file was stored. It was all controlled by Docker. So that is why it is not recommended that you use anonymous volumes. But anyways, let's find what all volumes exist on our system. So I'm going to do volume ls. This is the command that you use to list down all the volumes. Volumes, these are created by Docker. If you are given the name will be present. If not, Docker will create a long hash for it. That will be counted as the name. So that is why it is recommended that you always use a named volume, because they are easy to manage. So let's do a docker volume ls. This is the command to list down all the volumes, right? So we have all these. By hitting trial, I found out that my volume was this one, A5411, this one. So I'm going to copy this hash, and you can inspect what is inside this or some information about it. You can do docker volume inspect, and then you can just paste the hash. So this is the information. So it was created on 19th June. Driver is local, so there are some volume drivers as well. We do not have a label attached to it. There's a mount point. This was the mount point. So this is the source folder. This, again, as I told you in the picture, that this exists in the Docker area. So Docker controlled it. That is why we don't have any control where it was stored. So Docker controlled this. And this was the name. No? A pretty crazy name, right? You cannot remember this one. So since we did not give it a name, since it was an anonymous volume, the name was given by Docker itself. So now let's just list down the contents what exists inside this folder. We created one file. I hope to see that file inside it, inside this region, inside this folder, sorry. So I'm going to do a sudo ls. Since this is a restricted directory, I have to use a sudo. So when I do this, I see this. So let me just print what is inside it. Okay, and my file name is this. So I'm going to cat this. Just so you see the command clearly, I'm going to reduce the font a little bit. Right? So I'm just printing out what is inside that. So we wrote echo hello, right? So the hello should be inside this, right? So that is how we know how the anonymous volumes work and how the name is automatically given by Docker. Something extra that we can note about this is that we do not have a mode like we had it here in the mounts, right? We had a mode. We do not have a mode here when we create an anonymous volumes, because they are totally controlled by Docker and the permissions are by default for this, right? Now let's move on to the named volumes. Named volume, since you have to give a name to the volume, we have to create a volume first and then use that as the source, this source. So we'll use the name instead of a path this time, and we'll give the destination, and then we write the image name and optional command. Let's go back to the terminal and try this out. So again, I'm going to do a Docker run. Everything will be same, but here I'm going to use a name, right? But let's first create that volume. So the command is docker volume create, and I'm going to call it, let's call it day 6 volume, and it has been created. Just to verify that, let's do a docker volume ls. You see this? A day 6 volume has been created. So now let's first inspect this. What is inside it? So let's write day minus 6 minus volume. You see that now that we have a name, it is easy to remember and it is easy to use. Again, so this was created here. The name was day 6 volume and everything remains the same. Right? So now let's mount this inside the OPT folder. Again, the same thing. First, we'll write the source. The source is this time going to be just a name, not a path. So day 6 volume, that's the named volume. It has to be mounted in the /opt, and I want this to be read write. That is it. Let's go in the OPT folder. It is empty. I'm going to shift to that folder, create another file. I am living in named volume.txt. This is the file. So this file is here. I'm going to echo volume. Right? Let's exit this. The container has died. Docker container. Yes, the container is no more. But since we have persisted the data into a named volume, now it is quite easy. So let's do the Docker run again. Again, I'm using the same command. Let's go inside the Docker again. And now you have your file. You see? Now the file is persisted. So these were 3 different types of volumes. Let's look at the agenda. So we have seen the introduction. We have also seen the different types. We have also seen how to find the details about them. We have also seen how to use them in Docker Run. The last part is to know how to use them in a Docker file. I'm going to leave this as an exercise for you so that you can read it online about how to use a volume command in a Docker file. So whatever we have done directly on the command line, you can write the same thing but in a different syntax in your Docker file. If you can't do it, I'm going to show you that in the next lecture. So the exercise for today is to print the number of files in your present working directory when it is mounted inside the Docker container. You have to use a volume for this so that you can mount your present working directory inside the Docker and then run an ls command in that folder, pipe it using wc-l so that you can get the line counts. I'm going to show you how the line count is printed. So you need to do something like this. You need to do ls-t in the folder that you mounted. Then you have to do pipe wc-l. So this is going to show you the line count or the number of files in that mounted folder. The second part of this exercise is to study about the volume keyword and use it in your Docker file. With this, we have reached the end of this lecture. I hope you guys learned a lot. I hope the journey so far has been quite fruitful. If you have any questions, if you have any doubts, please post them in the YouTube's comment section. I'll be happy to help you guys. Till then, stay safe, stay home, and keep learning. Bye bye.